Okay, so this time around, we are going to talk about using Punnett Squares. Now, you guys have all used Punnett Squares or should have in middle school. This shouldn't be a new concept, so I'll try not to blather on too long. And there are lots of YouTube videos that will show you the same thing I'm going to walk you through. So I like to use pretend people to talk about this and to introduce some terminology. My pretend people are called Frida and Fred, and I like to talk about freckles. So Punnett Squares are a tool that's used to kind of help with the rules of probability and to predict the likelihood that two genes are going to end up in an embryo together. And so let's start with our couple here. We have Frida, who has some really crazy hair going on. And Frida also has freckles. And she's a happy person. Her partner, Fred, over here. Fred doesn't have so much hair. And he also does not have freckles, but he's still a happy guy. So Fred and Frida are wondering what are the chances that their small fries are going to have freckles. Now, for the purpose of this demonstration, we're going to say that freckles are a dominant characteristic. So having freckles is going to be caused by a dominant allele. So I'm going to just write this here. F equals having freckles. And lowercase f is no freckles. Now, like I said, I'm making this up. This is not a real trait per se. Yes, freckles are, but their presence or absence isn't necessarily linked to a single gene in a dominant recessive fashion like this. So, Frida kind of looks like she has chicken pox and not freckles, but Frida and Fred. So we want to know what are the chances that their offspring will have freckles. We need to know a little bit more about them, and that is that we need to know, at least we can start to talk about their genotype. So we've already talked about their phenotype, and the phenotype is what they look like. Okay, the phenotype could be your blood type, it could be the expression of a protein in the cell membrane, it could be whether or not you have a different color hair or eyes or skin. Those are all phenotypes. So the way something looks or the expression of the gene is the phenotype. Okay, expression of gene, the physical expression. Okay, so I often think of P and P. Now, the genotype goes along with that, and it is linked to phenotype. But the genotype is the allele combination that one has for a particular gene. So for any pair of genes, remember, you get two alleles, one from a mother and one from a father. We know that if Fred has no freckles, then his genotype is 2 or lowercase f's. Okay, because the only way to have a recessive phenotype is to have only recessive alleles, right? We can call Fred homozygous recessive. Now, if I told you that Frida's father had freckles, but Frida's mother didn't have freckles, then you could make the next assumption that Frida got the freckleless gene from one parent and the freckled gene from the other. So she would be considered heterozygous. And so heterozygous would be having two different alleles, in this case, the big F and the little f, but in some cases it's just any two different alleles versus two of the same here. And in this case, it's two recessive. You can also have a homozygous dominant, which we'll see in the offspring. And that's also two of the same, they just happen to be dominant. So Fred and Frida are both potentially donating. All right, they're having children, and they're each going to donate one gene. So Frida is either going to donate the big F or the little f. And Fred, well, it's going to be the same allele, but it's either that allele that came from, let's say, his mother, or the other allele, let's say, came from his father. So we don't have to have a Punnett square to predict the likelihood that they're going to have freckles. We could just use the math that we covered in the last video. There's a 1/2 chance of Frida giving her big F, and we know that there is a 1 in 1 chance of Fred giving his little f, because he's going to give one. So the likelihood they're going to have a child with freckles is 1/2 times 1, which equals 1/2. So the chances of a freckled-born child are 1/2. Now, a Punnett square just makes this math a little easier. So if we have our square here, there are 4 different combinations, and you can imagine these out if you want to, but Frida is going to fill in our left side of our box. She can either donate the big F or the little f, and Fred is going to donate either the little f or the little f, depending on which line they came down. And then you can fill your box in by filling up and down, or across and down. So big F goes in each box because it's on the same row, and the little f goes in each of those boxes because it's on the same row. And then down here, the little f goes from the left, and the little f goes from the top, and the same thing in the next box over. So we just found out the exact same thing. There's a 1/2 chance that they're going to have a child with freckles. So a couple things when it comes to Punnett squares. So that's the basics of solving them, but a couple things to think about when you're solving Punnett squares. And that is that the capital or dominant genes come first. And we often use the capital letter to represent a dominant gene because it's bigger. And then the recessive gene comes second. Choose your letters wisely. There are some reasons for this, and one of them is something like the letter M can look very similar when it's in its upper and lower. Here's a really good one. P. Which P is which? Which one's an uppercase and which one's a lowercase? And I know you say, well, I can draw it like this and it makes sense. However, when you start putting that into Punnett squares, it gets really sloppy. So be careful which letters you choose. A is a great letter because it's got a very different upper and lowercase. B is a great letter because it's got a different upper and lowercase. C goes in my category of not such a good choice. D is okay. E is a great choice of letter. F is okay, but depends on how you draw your Fs. It's tricky. G is another really good choice. All right, you get the idea. And later on, we'll talk about some more rules, but to start with, those are some things to think about. And also, when you're solving Punnett squares, you can make yourself what's called a key. So in our freckle demonstration, right? I'm losing some of my letters here. In our freckle demonstration, our key was this. We said freckles and no freckles. And the reason this is a nice thing to do is because as problems get harder, it's really nice to go back and remember, well, what symbols did I use for each of my alleles? Because all these are is a symbol for a freckles allele or a no freckles allele. Okay, so instead of having to write out freckles allele and no freckles allele every time, we write down a shortening, which is the letter F. There are times in genetics when people might use symbols, okay, to represent different genes, or maybe they're letters or number combinations. Fruit flies are pretty popular. They use this plus sign for a wild type. And then maybe they have other types of things, like they use this VG combination to represent what's called a vestigial wing, or almost the lack of a wing. Either way, that's just another way of writing down this trait. I think I've covered it. Let me know if you have any questions, and hope that helps.